Today we will begin a new chapter, that is chapter 5, Arithmetic Progressions. So before starting this chapter, first we have to know what is arithmetic progressions. But before knowing arithmetic progressions, you have to know about pattern. So I'll show you some examples of pattern. So these are the examples of patterns. You see here 800, 850, 9000, 9, 16, 25, 36 and so on. These are patterns because they follow certain rules in this list of numbers. So pattern is a list of number which follows a certain rules based on the previous number. You see here 800, this is 8000, 8500, 9000. It is increased by 500, again increased by 500. Next example, you see, this is also a pattern. It is increased but with a certain rule. 9 is a 3 square, 16 is a 4 square, 25 is 5 square, 36 is 6 square. So it follows a certain rule in this series of number. So it is a pattern. And similarly, this is also a pattern. 45, 43, it reduced by 2, again reduced by 2, you got 41. 39, it is reduced by 2, again reduced by 2, you got 37. And also you see here, this is also a pattern. 10 to 11, 11 to 13. So here it is increased by 1, again it is increased by 2, again it is increased by 3, again it is increased by 4. So all these are examples of pattern. But all these patterns are not arithmetic progression. Among them you observe, here it is increased by a fixed number, that is, it is increased by 500. From here to here it is increased by 500. But it is also increased with a certain rule, but a fixed number is not increased. It is increased by 7. And it is increased by 9, it is increased by 11. And you can say this is reduced by 2, or you can say it is minus 2, increased by minus 2. It is also reduced by minus 2. It is also reduced by reduced by 2. It is also reduced by 2. But among them, I'll tell you directly, this first example and the third example are arithmetic progression. Example of arithmetic progression. Because they increase or they decrease with a fixed number. So these two examples are arithmetic progression. So we can say an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So we can clearly say that arithmetic progression is a list of number. You see this example, this is a list of number in which each term, these are the terms 8000, 8500, 9000, each term are obtained by adding a fixed number. Here it is adding a fixed number, that is 500, fixed number adding and getting the next term. Again in this previous term you add a fixed number 500 and getting the next term. Saying about this, adding a fixed number to the preceding term except the first term, except this first term. We don't add any number to the previous number to get this 8000. So all the terms are obtained by adding a fixed number to the preceding number. So this list of number is called arithmetic progression. Now I'll show you some basic codes which you have to know to solve the problems in this chapter. So I'll show you, this is an example of arithmetic progression and it is increased by 3. 7 to 10, it is also increased by 3. It is increased by a fixed number, increased by 3. It is increased by 3. So this is increased by a fixed number. So it is an arithmetic progression. Now this first term is indicates with A or A1 and the second term is indicates with A2. This third term is indicates with A3. You have to know all this code and so on. So the first term it indicates with A, and here you see here this fixed number, the fixed number that is increased everywhere is called a common difference. This is called the common difference of this AP. So and it is indicates with D. So we can write here common difference it indicates with D. How many numbers of terms are here? 1, 2, 3, 4, 5. 5 terms are here. So this number of terms it indicates with N. So for this example I'll show you what is the first term here. Here the A value is 4 because the first term is 4. What is the D value here? D means common difference. Here the D value is 3. And number of terms, that is N. What is the N value here? How many terms are here? 1, 2, 3, 4, 5. 5. So you have to know all this code. What A4, what D4, what is N4. And one thing you have to remember here, D, that is the common difference, can be obtained from any two terms, any consecutive two terms. How? You just find a difference between the two terms, that is any next term minus the previous term. That is indicates like this: A k plus 1 means any term minus preceding term, it will be AK. AK plus 1 term minus its preceding term will be AK. Now after knowing all these basic things, you can solve all the exercise you can solve the exercise 5.1, which will be explain you in the next class. For today only this much. Thank you.